dividing two functions. There's the nice notation and the not nice notation. I've also seen not nice notation look like this. And again, anytime that you have not nice notation, if you had f divided by g of 2, which is the same as that, change it to that, and then you could calculate it. Now, the domain of our red graph is restricted. That's right here. X is bigger than or equal to -2. So our green graph will also be restricted by that, but we also realize that since there's an asymptote at the non-permissible value of your blue, because you can't divide by 0. So when the blue graph is equal to 0, we have a non-permissible value. That gets added into the domain of our green graph as well. So not only is it restricted by the red graph, where the red graph exists, x is bigger than or equal to -2, we also have to add to our domain the non-permissible value. So when we go to example 2 to work on this, use the graph of f of x, which we'll do in green. Just a reminder, square root graph looks like that. And g of x, which is a straight line like that. State the domain of f of x and g of x. So part A, f of x, the domain is when x is bigger than 0. The range is y bigger than 0. For our blue graph, the domain is everything, and the range is everything. In part B, we want to write an explicit equation for q of x, which is f of x. So on the top, I'll write the square root of x divided by g of x, which is x minus 2. And now state the domain and range of this graph. Well, the domain we can find out because of the restrictions. It has to be bigger than or equal to 0 because of the square root. But we also have a non-permissible value when x is 2. So we also have to write x can't equal 2. And the majority of your exam is going to be asking questions about domain. To figure out the range, this is where you may have to draw the graphs to see, because this is not something you're familiar with. We never graphed a square root divided by a line. In our polynomial graphing unit, we did parabolas divided by lines, but never square roots divided by lines. So we're going to see what can we do just by drawing both of our graphs. So here I'm going to draw my original green graph, which was my square root graph. So all of those things in transformations unit, you have to know how to graph your parent graphs really quickly. And my line x minus 2 should have a y-intercept of minus 2. So what I've done is I've drawn my two graphs. And now I'm going to take my green graph and divide it by my blue graph. And I'm going to draw that final graph in purple. Okay? So my first point is when x is 0. What is 0 divided by -2? That's 0. My next point that I have on my graph, my green graph is 1. My blue graph is -1. What is 1 divided by a -1? -1. My next point is when the blue graph is 0. And when dividing by 0, that's not possible, so we will get an asymptote at x equals 2. My next nice point is when both of these graphs are at the point 4, 2. And if I divided my y values, 2 divided by 2 at that point, I get 1. So I had 3 nice points and an asymptote so far. How am I going to graph my purple graph? Well, first of all, I know that my purple graph doesn't exist when x is less than 0. And because of this asymptote, you can probably see that that graph is going to go in that direction. Something connected to what we did in our graphing rational functions unit. If I look at this, the highest degree, if I change q of x, I can change the square root of x to x to the half, and on the bottom I have x to the minus 2. My highest degree is x to the 1. It's smaller on the top because the degree is x to the half. What happens when we have a bigger degree in our denominator? Do we get an oblique asymptote or a horizontal asymptote? Do you remember? When the degree is larger on the bottom, we get a horizontal asymptote. And that horizontal asymptote, when it's bigger on the bottom, is always at y equals 0. So because of that information, if you did more points, you would find out that this part of the graph looks like this. And now that we've graphed it, what's the range of our purple graph? This is probably the most complicated range you'll ever do. Well, one of them. So the range is the y values. And what you'll be tempted to say when you look at that is that y is everything, but y can't equal 0. Can you see yourself being tempted by that? When in reality, y is everything, because at 0, we have a point at 0, 0. Even though there's an asymptote that shows later on that it can't equal 0 as x gets big, this domain is everything. I mean, this range is everything. Okay, questions for practice on this one are 6, 13, and 16.